Good evening, everyone. I hope everyone can hear me clearly and you guys can see my screen. So today topic is flash memory dumping using ATT5 badge, which is built by ATT5.com.co. Before starting this, I just want one confirmation. Are you guys able to see the screen and listen me properly? If you are able to, then please ping OK in chat so I can get the confirmation. Okay, perfect. So let's start with this session. So first, let's start with my small introduction. So myself, Ujjwal Patel, and I'm working in security, consulting, and auditing, and currently I'm working in Ernst and Young. I started my career as a researcher in Indian Space Research Organization, which is in Ahmedabad, India. I'm active member of Seaside Security Conference, and I'm passionate about the hardware hacking since I like to get my hands dirty in it. And recently, I started working on car hacking also, and we are looking into it. So today's topic abstract is flash memory dumping. The test case objective is to dump the flash memory of the JTAG protocol using ATT5 badge as the attacking hardware against the damn vulnerable insecure app. So this ATT5 badge is built by ATT5 company itself, and this damn vulnerable insecure application for IoT is built by Exploit. And today we're going to hack this Diva board using ATT5 badge. This badge will be the interceptor, or we can say a bridge to the specific hardware, and the protocol will be the JTAG, which we're gonna use to hack this Diva board. So for that, let's get started for this session. And in that, let's start with the hardware configuration. So first, hardware which you're gonna use is this Diva board. So Diva board is the connected to IoT device and vulnerable target board designed to teach the basic of IoT security. So this board basically having a Zigbee protocol on it, which is connected with the STM32F411RAT CPU, and which is having JTAG enable, SPI to enable, and UART also on board itself. So the board provides a standard JTAG debug interface as well as the SWD interface that can be used as a debug port for firmware debugging and UART port for custom console for debug message on the terminal. There are three breakout header on the Diva board, and we will scan the breakouts and we'll find the debug ports. So for debugging purpose, we have to understand which pinouts are responsible for the JTAG protocol. So for that, we need to identify the pinouts. For that, we have used the JTAG num. So JTAG num is the open source tool which we can create it using Arduino board, which I haven't shared those information in this session because this session is specifically for flash memory dumping. So if he wants to understand that, just Google the JTAG num, which is built on Arduino Uno R3 and which it is available on GitHub. Next thing is ATT5 badge is a hardware tool that allow you to interact with the various hardware interface and ports such as UART, SPI, I2C, JTAG, GPIO, and so on. The ATT5 badge make use of FT23H, which is the bigger and powerful version of the FT232R. So in case you have been involved in electronics, you might have heard of familiar with FT232R, which supports several serial protocols, and it's widely used in a number of JTAG adapters. And it's also used for USB to UART adapter, and it series supports to several protocols, and it's also found to be widely used in number of JTAG adapters. So these are the pin configuration with the ATT5 board. So as we discussed about this board, we have a pinouts over here, which is responsible for JTAG protocol, and we're gonna connect with this badge, and the pin configuration would be look like this. The taste clock pin will be connected with the data 0 pin of the 885 batch, and the connection look like this. So I have already connected both of the hardware, and I will just connect this hardware with my machine, and we will attack this exploit nano board. So for exploitation part, we need to set up these things before. So this pinout configuration and the CFG file. So CFG files is are useful to connect with the hardware. Let's say we are using ATD5 board, and we need to understand how it is getting communicated with the computer device. For that, we need some basic configurations file, which is called configuration file, and the extension of its .cfg. And so basic introduction for CFG file is generic preference file that stores settings and configuration information. In computing, a configuration file are used to configure the parameter and initial setting for some computer programs. They're used for user application, server process, and operating system settings. So as you can see in the screenshot, we have already wrote the 885 configuration file, and in that, as you can see, there are some functions has been called out in it. First one is FTDI, VID, PID. So VID and PID is responsible for vendor ID and a product ID, and FTDI layout in it is basically a port number. And this is how this configuration file will communicate using our machine to our 885 badge. And for the understanding of VID and PID, we have to have the proper exact number, the hex value of the VID and PID. So for that, we has to refer the documentation of the chip itself. So in our case, as we have mentioned earlier, like we are using the FT232HQ, and for that we have the documentation available on this slide, which is saying that this FT232HQ having 403 and 6014 respectively vendor ID and product ID. So we're going to use those ID in the configuration part, and using that we will make a proper connection with hardware, which is 885, and 885 will connect with the exploit nano DAM vulnerable IoT board, and we will hack the vulnerable IoT board using 885 badge. So next part is exploitation. So we will move on to the exploitation part. For that, we will connect our hardware. So first I'm connecting my DAM vulnerable IoT board, which is connected with my virtual host, and another is my 885 badge, which is also connected with my machine now. So for the cross verification, we will check the LS USB. So we have list of USBs connected with the machine. So first one is, as you can see, it is FT232H, which is our 885 badge, and another one is STM microelectronics, which is our Diva board. So for better understanding, we will see what is this ST microelectronic virtual COM port. So we will try to connect with that board, and we'll look into it exactly what for it is used for. So for that, we will check the drivers of it. So as you can see, we have two drivers available to be connected, and one is respectively used for the 885 badge, and another one is for the IoT board. So this ACM0 is for the IoT board, and we will use the screen to connect with the board. And using screen command, we will try to connect with it, and we're going to mention the port number ACM0, and the board rate value is 115200. So as you can see, right now we are inside the Diva board. So and we will try to run a basic command, a list of functions. So as you can see, we are able to see the list of challenges in that. And in that we have UART port lab, I2C sniffing lab. So basically the different port attacks, and we have also JTAG lab. And in that, as you can see, we have firmware analysis lab. So we will understand how we can extract the firmware from the flash memory, So we will able to understand the information available in the firmware, and if we are able to get the password or something from it. So as we run the fourth one of firmware analysis lab, as you can see, they're asking for the password. So if we don't know how to get the password, but we will try to dump the firmware first and we will understand how it goes. So for that, we will use the tool called OpenOCD, which is a debugger basically, which will help us to run, which will help us to bridge the connection and debug the whole hardware with it. So basically, so I'll just move into the directory where my configuration file is available. So this is my configuration file for Attify batch, which is have also already mentioned the port number and the VID and PID. So we'll run the OpenOCD for this and we'll use it. Attify JTAG C. For this C is basically for command. So we are telling Attify batch to select the JTAG protocol. So we are going to debug the JTAG from this STM32F. So it's a configuration file for the IoT board. So when we install OpenOCD in our machine, so the OpenOCD by default installs so many configuration files by default. So it's available on user share OpenOCD, and like wherever the OpenOCD has been installed, we can uh, like we can travel to script directory and we can list out the targets. So in the target, we can see the number of CFGs available already. So we can directly use the CFG from there. So I'm using that CFG for this STM32F4 because this particular IoT board is using this CPU. So we can use it. And now if we just hit enter, we can see that the communication is established. The connection is established and we can listen it on port number 444 or 666. So next step would be we will check like are we able to communicate on this port or not. So next part will use telnet to connect with the port and we will see. So as we can see the the communication has been established successfully and we can see the open on chip debugger which is basically open OCD, and we can see it here also accepting telnet connection on TCP 444. So from here we can tell like we can give any command to the hardware which will send it to the IoT board. So if we just say hold to the machine, so this STM32 will accept this request and the whole memory location and everything will be on hold. So all the processes which are running in behind will be on hold. But in our case, uh, we wants to dump the whole firmware. For that we need to run we need to resume all the processes which is running behind. So for dumping the firmware, there are different commands available already in the OpenOCD documentation. So let me just share that first. So so this is the documentation for on-chip debugger. And in that, every single commands has been already listed down here. So we can use a dump image for this specific session, dump image. And this is the command which we're gonna use it for dumping the flash memory. So for dumping the flash memory, we need to understand where it is actually stored. So we need a exact memory locations for the specific uh, CPUs. So like in our case, it's this is SMT32F, and we're gonna use the flash memory of the flash memory location. Yeah. So as we can see here, uh, Wait, let me just open the screenshot for the better understanding. Yeah. So as we can see, this is the memory location and allocation for the STM32F4. And in that, as we can see, that is running from 0x0800 and it's reserved till 0x07FFF. So we're gonna use that only to dump the firmware. So it's starting from 0x08 till 0x07FFFF. So same way we will just move on to our terminal and we will run it. So we will just run dump image and we'll give the absolute path, which is home Kali. And let's say because I'm just giving board underscore CFG and the name of the file. So firmware dot bin, and we're gonna mention the memory locations for that. So these are the memory locations 0x08 and 6 zeros. And the the reserved location still 07 F. Okay. And we're just gonna hit enter. So it's being processed, and as we can see, it says dumped 524287 byte of data in this particular location. So we will just move to that directory, which is in board.cfg. And as you can see, we have the firmware.bin with us. Now this firmware.bin having the all of the information which has been stored in between of this flash memory. So we can check the whatever information has been stored into the flash memory from directly here. So for reading this bin file, I'm using this string command, and which will help us to list out whatever stored inside it. So I'm just giving strings firmware.bin, and it, as you can see, we have the numerous information has been listed here. So we will try to understand what is happening in this firmware, and we will try to find out the password for this particular challenge. So our challenge was firmware analysis lab, and they are asking for the password. So in the beginning of the firmware, we have the some garbage value, and then we have some information related to admin, and then it is saying this is secret. Then as you can see, we have a please log in, and it is saying please enter the password, access granted, access denied. And after that, at the end, they are they have exit the that particular terminal. And after that, they might have log in again, and we have the backend percentage as, then they are saying firmware analysis lab. So before logging into the firmware analysis lab, they are asking for the password. So this could be the password we can assume here, and we can just use it. So let's try to enter the password here. Before that, let's check if is there any other password. Like at the end, they are saying password has been updated. So look for the other things which is seems like a password. So it's saying welcome to percentage s. So percentage s. Oh, here it is saying this is secret. Yeah, so there is the only one thing which is seems different in whole list. So we will try to add it in the here back end space percentage It was S, no? Okay, so I have typed wrong. Okay, so we have to do it again. 4 and percentage space percentage S. Yeah. So as you can see, it says access granted. So from here, from the OpenOCD console, we have connected to the Attify badge. So Attify badge given as it's modulate or given command to access JTAG protocol only. And at the end, we have mentioned that we gonna uh, command this particular hardware, which is IoT board, which we have from the exploit, and it is having the CPU STM32F4X, and it's turned on the port number 444. We connected to the port number and we just give some basic command like dump image, and using that we have mentioned the flash memory location, which is already available on the data sheet of the CPU. And at the end we got the firmware in our machine, and we just use string command to read it, and this is how we are able to dump the flash memory. And at the end we just want to verify some basic thing, and we run the hardware itself, and we understood the firmware also. So this was the practical part of the flash memory dumping, and it's an ending of the session also. It was a very small and simple session, and if you have any questions, you guys can ask. Okay, if there is no question, then I'm taking it as no, and I'll just uh, request our presenter to take lead of it.